Hi, my name is Kirk Mason. I'm an AI ML solution innovation consultant at Snowflake. Today I'm going to show you how you can train and deploy models using Snowpark for Python and Snowpark ML. This is incredibly valuable because it gives data scientists the ability to build models right where their data actually resides. I'll also cover additional features like Data Marketplace, Snowflake Notebooks, and Streamlit in Snowflake, all valuable tools for a data scientist. We'll learn about these concepts by helping a fictional food truck company called Bytes pick the best locations to park their food trucks at each shift. To do this, we'll build a model that predicts the shift sales, and then we'll deploy that model to a Snowflake Model Registry. So let's jump right in. First, we'll get some data from the Snowflake Marketplace. SafeGraph has provided free location data that includes things like latitude and longitude that'll help us find the optimal location for each of our food truck drivers. So we can go to the search bar and click and search for SafeGraph Frostbite. And then we'll select this first option here. And then to get access to the data share, we click Get. In the options dropdown, we can change the database name to Frostbite_SafeGraph. And let's have the role be public, so that way we don't run into any permission issues. And then click Get. And this is going to give us access to the SafeGraph data without actually transferring the data over into our account. Now that we have the data from the Snowflake Marketplace, we can run the rest of our setup. Here you can see the SafeGraph database, and you can see that it came from a marketplace share. This is a SQL script that we'll use to create all the necessary objects that will be used during the demo. I'll walk through this at a high level without going into too much detail. But first we use the role account admin to create a dev database. And then following data engineering best practices, we create three zones. We create a raw zone, a harmonized zone, and an analytics zone. The analytics zone being the schema that will be used by data scientists and analysts to build their models and run their analysis. Next, we create an external stage that has a file format associated with it, a CSV file format, because our data is in CSV form in an S3 bucket. Then we create a warehouse that we'll use. Next, we'll use the role of security admin to create a new role called Bytes DS role. That's the role that we'll be using during the demo. And then after that, we set up role-based access control for that new role. So then we can grant access to all the database schema and other objects we'll be using to the Bytes DS role. Finally, we set up the data sets we'll need. So first we ingest into the raw layer the CSV data from our external stage. Next, into the harmonized schema, we'll join that data to our SafeGraph data. And finally, we'll create a view of that data set in the analytics schema. And here you can see a few rows of that final data set. So now that our setup is complete, let's learn how to use Snowpark and Snowpark ML to build and deploy a model. First, we'll come over to the Projects tab and click the Notebooks button. We're going to build and deploy this model in a Snowflake Notebook. Let's go down here and change our context to the data science role we just created, the Bytes DS role. We could create a new notebook from scratch by hitting this Notebook button here. But we are going to import an already existing notebook from a file. So we click the drop down, click Import IPYNB file, and select the file we'd like to import. We can name our Snowflake notebook whatever we like. We'll name ours Bytes Snowpark 101. Then you select a database and a schema to house the notebook. And our notebook is going to run inside a Snowflake warehouse using Snowflake Compute. So we need to select the warehouse we would like to use and click Create. Now that we have our notebook, we're going to put ourselves in the shoes of a data scientist at a fictional company called Bytes. Bytes is one of the largest food truck networks in the world, operating across 30 major cities in 15 countries, and their goal is to achieve 25% year-over-year sales growth. So as a data scientist, we're going to support this goal by helping the drivers more intelligently pick where to park for shifts. What we want to do is direct our drivers to locations that are expected to have the highest shift sales. To do this, we'll build a model that will train on historical shift sales data, and then we'll use that model to predict future shift sales. In this introduction to Snowpark and Snowpark ML, we will use Snowpark to explore the data, perform feature engineering. We'll use Snowpark ML to do pre-processing and train a model. And then we'll deploy that model to a model registry in Snowflake. And then finally, we'll interact with the model in a Streamlit app in Snowflake. Some of the benefits of using Snowpark and Snowpark ML are no copies or movement of data. You're moving your modeling process to where your data lives. In doing so, you maintain the security and governance provided by Snowflake. You can leverage Snowflake scalable compute so you can scale up or down easily as needs arise. And Snowpark ML provides a fast and convenient way to build models in Snowflake. Before we begin, we'll need to install a few standard Python packages that the notebook will need. In order to do that, we will go up here to the packages dropdown, and we will search for these three packages. So first we'll search for Snowflake ML Python, and then we'll get matplotlib and plotly. Now that we have our packages, we can click Start, and that will initiate the notebook. Now that our notebook is active, we can begin to work in the cells. A Snowflake notebook is just like a Jupyter notebook. It's a cell-based interactive programming environment. A nice feature of Snowflake notebooks is that in addition to Python and Markdown cells, you have access to SQL cells where you can write SQL code. For this introduction, we're going to be using Python. This first cell here is our import cell. This is where we're going to import the packages we need. And you can see that importing Snowpark and Snowpark ML packages is the same as importing any package in Python. First, we import some Snowpark elements. So we'll import session, and that will be our bridge between the notebook and Snowflake. That will let us connect to Snowflake and access the data that is in Snowflake from the notebook. We'll import functions as F and types as T. We'll also import window. This will help us create some rolling average functions. And then next we'll import Snowpark ML objects and classes. So Snowpark ML is an API that uses familiar Python frameworks such as scikit-learn and XGBoost for pre-processing and training models inside Snowflake. The advantage of using Snowpark ML is that the syntax is very similar to what data scientists are used to with scikit-learn or XGBoost or LikeGBM. You can use very familiar syntax, and it runs directly in Snowflake without having to wrap the code in a stored procedure or a user-defined function. So here we import simple imputer and one-hot encoder. These are a couple pre-processing steps. We have multiple pre-processing steps available to us in Snowpark ML. Just check the documentation out to see what's available. We're also going to import linear regression. This is the modeling class that we'll be using to train our model. And then we're going to import pipeline. Pipeline will help us wrap the pre-processing steps and the linear regression model into a single object. And then we'll import registry. This is the model registry that we'll use to log our model. And finally, we'll import some metrics that we can use to evaluate the model performance. So once we've imported everything we need to import, we can connect to Snowflake. Connecting to Snowflake inside a Snowflake notebook is extremely easy. All you have to do is import getActiveSession and then run the function getActiveSession. And now we have a session object. And again, the session is our connection between this notebook and our data in Snowflake. If you were to run this notebook locally, say on your laptop, you would create the session slightly different. You wouldn't use the getActiveSession function. You would get a different package from Snowflake Snowpark. But the session would serve the same purpose. If you do want to download the notebook so you can run it locally, you could hit these three dots up here and click export. You would just have to create a local environment that has the packages that we installed above. You'll also notice that our session has its own context. So you see it has a role and a warehouse, a database, and a schema. These were inherited from the notebook. If you recall, when we set up the notebook, we specified what database, schema, and warehouse we wanted to use, and we created the notebook under our tasty DataBytes DS role. If we want to change any element of that context, we can with session methods. So for example, we could use the use role method to change our role, or the use warehouse method to specify exactly what warehouse we wanted to use. Use warehouse is very useful throughout a notebook if you ever want to scale up or down during your workflow. Now that we have our session, we can start interacting with our data in Snowflake. To do that, we'll create a Snowpark data frame. A Snowpark data frame is a data structure that contains rows and columns. It's similar to a SQL table, and it's a familiar representation of data for Python users. Here we create a Snowpark data frame called Snowpark DF by simply using the session.table method and giving it the name of the table that we want to reference. We can look at the data with the show method, and this gives us instant access into our data. You can see the first 10 rows of the data frame displayed below here. And from this, we can tell that there are multiple cities, multiple location IDs. We see our date column here. We can also see null values in the shift sales column. The shift sales is the column that we're going to be predicting. And in this data set, null values indicate future data points. Anything in the past will have a shift sales value. So this is how we can separate our data set into an inference set and a training set. You'll also notice multiple additional features like city population, latitude, longitude that can be used to possibly train the model. And then we have our shift column here. And this will be either AM or PM. After we look at our data, we may need to do additional transformations. Snowpark offers efficient transformation pipelines using Python syntax and chained logic. So here we can take our Snowpark data frame, we can select a handful of columns, and we can call that new data frame location data frame. Then we can chain additional transformations and pieces of logic onto that location DF data frame. So here, we additionally filter down to a single location ID, and then we sort by date and shift. We can inspect the first 20 rows of this new location DF data frame. We can see that we've filtered down to one location, and you can see the point at which the historical and future data sets are separated. Snowpark works in two main ways. First, the data frame API takes Snowpark code, like what we just saw, and converts it to SQL under the hood before running it in Snowflake. This allows you to write code that is often much cleaner than the underlying SQL. The other option is to run Python code from familiar packages like pandas and NumPy by wrapping that code in a Python user-defined function or stored procedure. The code will then run in a secure Python sandbox on the Snowflake warehouse. Today, we will focus on Snowpark and Snowpark ML APIs, so we won't be explicitly defining functions and procedures. To illustrate how our Snowpark data frame code is executed as SQL, we can look at our query history in Snowsight. So the code that we ran up above to select, filter, and order by looks like this in our query history. We can see that there's a select from our table. Here's our filter, where location ID is 1135, and here's our sort, our order by. If you don't want to toggle between Snowsight query history and your notebook, you don't have to. You can run the explain method on the data frame to get information about the query that was run. And to further illustrate the point that data is not copied or moved out of Snowflake when you're using Snowpark, we can compare the data frame size of a Snowpark data frame to a pandas version of that data frame. So here we take 10,000 rows of our Snowpark DF, and we use the toPandas method to convert it to a pandas data frame. The Snowpark DF has 0 memory footprint, whereas the pandas DF does take up space. So whenever you run toPandas, it brings your data to your local environment. Because we're using a Snowflake Notebook, the local environment is the Snowflake warehouse that the notebook is running on, But if we were to export this notebook and run it on our laptop, then Two Pandas would bring the data client side to the laptop. Now let's do some exploratory data analysis. Snowpark makes it possible to leverage native Snowflake performance and scale for aggregating large data sets as we explore the data. And then we can easily transfer that aggregate data to the client-side environment for visualization. So as I go through the next few cells of code, I'll highlight which pieces are being done on Snowflake and which are transferred client-side. And once again, because we're using a Snowflake Notebook, client-side is still the Snowflake warehouse. Whereas if we were to download this notebook, client-side would be your laptop or whatever machine you're using to run the code. So first, let's find out how many rows there are in our data. We'll run the count method, and we'll determine that there are close to 2 million rows in the data set. And this was calculated in Snowflake. No data was transferred. Next, we'll calculate some descriptive statistics. We'll use the describe method, and then we'll convert those statistics to a pandas data frame. So the summary statistics are being calculated in Snowflake, and then bringing over those aggregate values client side to display this pandas data frame. It might also be important for us to figure out which columns are numeric and which are categorical. So here we can use a list comprehension, which is a pretty familiar Python convention. And we are using it on Snowpark syntax. We're accessing the schema attribute of the data frame, and we're extracting the data type from each of the fields. If it's in the numeric data types, we add it to our list called numeric columns. All of this is taking place in Snowflake. And we'll do the same thing with our string columns to find out what our categorical features are. And here we see that we have city, shift, and location name. Those are all string columns. Shift, we want to use in our model. And the linear regression model that we'll be using can only accept numeric features, so we'll have to transform this at some point. Next, we're going to calculate the average shift sales by city and visualize it. So here we perform a group by, and then we get the average shift sales within each group. We rename the column average shift sales. This analysis data frame we created, we will chain a sort onto that, and then we will bring it into pandas to visualize it client side. So now we get this bar chart that was calculated locally after the aggregate statistics were calculated in Snowflake. So all that was brought over is the aggregate values. And here you can see which cities had the highest average sales versus those with the lowest average sales. Maybe we want to narrow it down to a single city to see how one city might behave. So here we can filter down to Vancouver. We're redefining analysis data frame. This was the data frame we created above. Now we're redefining it. We're chaining a group by and getting the mean shift sales for just this one city. All of this is taking place in Snowflake. And again, just as a reminder, this analysis DF is really just SQL under the hood. So this isn't holding any data, it's just storing the SQL that will be executed. And then we can run a count on that to find out how many individual locations there are in Vancouver. And finally, if we want to visualize the distribution, we can take that analysis data frame and bring it to pandas. So we take our aggregate values, bring them client side to visualize the histogram. And we can see that the majority of shift sales for Vancouver are somewhere between $180 and maybe $225. Next, we'll create a new feature for our model using the window function. We will first define a window that partitions over location ID and shift and orders by the date column. And then over that window, we're going to get a rolling shift average. Window functions allow us to aggregate on a moving group of rows. So now that we have the window, we can calculate the average shift sales over that window. And here we've created a new column called average location shift sales. And you can see in that column that we have some null values. We're going to have to address that at some point if we want to use this in the model. We could use Snowpark code to fill in those null values. Instead, we'll use a simple imputer from Snowpark ML as a pre-processing step in our modeling pipeline. So let's start building our model. The first thing we need to do is separate out the historical records from our Snowpark data frame. If you recall, the shift sales column had null values for future dates. So all we need to do is grab the records and filter the ones where the shift sales is not null. And now we have a historical Snowpark DF. Next, we need to split that into a training and test set. We do this so that we can train the model on one set of records and we reserve a test set that isn't seen during training so that we can evaluate how the model might perform on future unseen data. In order to do this, we will find the date range of our historical Snowpark DF using the ag, min, and max functions. And then we will set the test start date to be 1 year from the most recent historical record. So we will reserve the most recent year for testing and train the model on everything before that. So we have our test start date, and then all we do to create the train Snowpark DF is filter to records where the date is less than the test start date, and then the test Snowpark DF will be all records where the date column is greater than or equal to the test start date. Now that we have our training data frame, we can build a model with it. We're gonna build our model using Snowpark ML. Snowpark ML is an integrated set of capabilities for end-to-end machine learning, and we're gonna use a pipeline to build the model. And a pipeline is a tool that sequentially applies a list of transforms followed by a final estimator. And this streamlines the process of pre-processing and modeling by combining all these steps into one single object. You can see that our Snowpark ML pipeline contains 2 pre-processing steps followed by a model estimator. So the first pre-processing step is a simple imputer. We'll specify that we want to replace null values that are in the average location shift sales column. That is the feature we created above with the window function. We want to replace those missing values with zeros. After that step, we want to one-hot encode our categorical feature. The shift column contains string values AM and PM. We want to create a new feature called shift_AM that will have 1s if the shift is an AM shift and 0 if the shift is a PM shift. And then after the one-hot encoding step, all of the columns will go on to the linear regression step. If we don't want the model to be trained on any columns in particular, we can specify those in the pass-through columns argument. So here you can see our model will not consider location ID, city. We specify our label columns. So this is what we're predicting is the shift sales. And then the output columns argument says what we want to name the forecasting column. So once we make our predictions, they will be placed into a column called forecasted shift sales. After we construct the pipeline object, we can fit it with the .fit method, and this is going to train our model. So we're going to train it on our train Snowpark DF data frame, so on a training set. And in this one line of code, we have trained a model. In the past, before Snowpark ML, you might have built this pipeline using sklearn, and then you would have wrapped it in a stored procedure to run on Snowflake Compute. Now through Snowpark ML, you can omit the stored procedure step and run the pipeline fitting directly in Snowflake Compute. Next, we'll examine feature contributions. So this model is not a black box. We can inspect the linear regression coefficient estimates to get an idea of how each feature is affecting the model. In order to do that, we take our pipeline. We say we want to look at the last step in the pipeline, which was our linear regression step. And then we're going to convert it to sklearn. So a nice feature of Snowpark ML is that because it is based on scikit-learn, or if you're using XGBoost or LightGBM, it'll be based on XGBoost and LightGBM. You can convert these objects, in this case, to sklearn using the toSklearn method. And now we have the sklearn version of that model. And from that, which we're calling model step, we can extract the coefficient estimates and display those as a table. And here you can see that the AM shift has a negative coefficient, so that we can expect AM shifts to sell about $18 or $19 less than a PM shift. Next, we'll evaluate model performance. This is a critical step when you're developing a model. You want to get an idea of how your model might perform in the future on unseen data. So Snowpark ML has multiple evaluation metrics available. Here we're going to be looking at mean squared error, mean absolute percentage error. All of these calculations, again, are being performed on Snowflake compute. All we do is we take our pipeline and we say .predict on our test set. And then once we have our test predictions, and you'll recall those are going to be in a column called forecasted shift sales, we can compare the forecasted shift sales to the actual shift sales for each of the metrics. And here you can see we've stored them in a dictionary called test metrics, and we are going to register that dictionary along with our model into the model registry. And finally, in the model development phase, we were using a subset of our historical data as our training set. We were omitting the most recent records to test on. So right before we register our model, since we like the performance of it, let's go ahead and fit it to all of our historical data so that it's trained on the most recent data. Now we're ready to deploy our model. Deploying a Snowpark ML model in Snowflake is as easy as logging that model to our model registry. A model registry is a centralized repository that lets you effectively manage and organize machine learning models, and Snowflake provides a model registry that allows you to store models and their versions along with metadata, such as the performance metrics related to each model. And this greatly streamlines model deployment. Before model registry was made available, if you wanted to do inference using a model, you would have written a UDF with the Python code to perform that inference. Now you can perform inference directly out of the model registry. Model registries in Snowflake are schema-level objects, so an account can have a single model registry or multiple model registries for different purposes or business units depending on the need of the organization. If a registry does not already exist in a schema, then the first time you log a model, that registry will get created. First, we establish our registry. The registry that we're accessing will use the schema associated with our session. Then we will log the model simply by using the log model method. We say we want to log the pipeline that we built above. We're going to call the model shift sales forecaster, and we want to log it alongside our test metrics. If we want to look at the models that we have in our registry, we can use the show models method, and that'll display all the models that are in the registry of that schema. And here you can see we only have one model right now, our shift sales forecaster model. Over here, you can see that we have one version. If we were to run this again and log the model a second time, a second version would get created. So I'm running it again. And now when we do show models, you can see a second version has been created. If we want to dig into each version, we can use the get model method and say show versions. And here you can see our two versions. You can see that the first one is set as our default version. You have the option to change default versions. You can see here when each version was created, the version names right here. And if you scroll all the way over, you can see the performance metrics that we logged with each version of the model. And that's it. We have now deployed our model to Snowflake, and it's ready to be accessed for inferencing. Inferencing from a Snowpark ML model that's been deployed to the model registry is a fairly straightforward process. First, we will get an inference data set. So in this example, we want to predict the very next shift sales so we can select the best location for our next shift. So here we will use our Snowpark data frame. We will only get the future data points by getting records where the shift sales are null. And then we will specify that we want tomorrow's shift in the AM. And let's, for the sake of this example, focus on one city, Vancouver. So now that we have our inference data set, we can make predictions with just a single line of code. Here, we take our registry object that we established above. We say get model. We specify we want to use the shift sales forecaster model. And if you recall, there were two versions. We're telling it we want to use the default version. And then we access the predict method by using run. So we say run predict on our location predictions DF, which is our inference data frame. And here you can see first three records of that predictions data frame, and we have our forecasted shift sales. Now we're ready to use these predictions to make better decisions about where to park our food trucks. To do that, we'll use a Streamlit app that the drivers can access to pick the location with the highest predicted shift sales. Here you see an app we've built in Snowflake using Streamlit and Snowflake. To use the app, you would select the city, let's say Vancouver, and the shift, and click update. This is going to perform inference and give us the predictions for each location in Vancouver. So if we're trying to decide where to park our food truck in this area, we could park it here and expect to maybe get around $180 for the AM shift, or we could park it here and get close to $240. We're able to determine the optimal place to park our truck. The code to run this app is pretty straightforward. Here we import our packages just like we did in the notebook. Right here, we create our header and our subheader, which you see over here. We use get active session to create our session that connects us to our Snowflake data and the Snowflake registry. The select box over here lets you pick a city. Right here, we have a radio button that lets you pick AM or PM. And then we create a function called get predictions. And this function will prepare our data. So we have an inference data set. We need to create that average location shift sales feature over our window. Then we filter down to tomorrow's date because we want to get the next shift predictions. We establish our registry. And then we say get model shift sales forecaster. We specify we want the default model, and then we run the predict method. To actually call that function, the user will click the update button here, and it calls the get predictions function. Right here is the code to display the map. And then down at the bottom, we tell Streamlit to display the table. And that's everything that's behind the Streamlit app. And it's totally powered by Snowflake. All right, let's recap what we did today. We accessed location data from the Snowflake Data Marketplace and used it as a feature in our model. From a Snowflake Notebook, we used Snowpark data frame operations to explore and prepare our data. Then we ran pre-processing steps and trained a model in a Snowpark ML pipeline, and we deployed that pipeline to a model registry. And finally, we built a Streamlit app that leveraged the model from the registry to help identify the best locations to park our trucks. Pretty easy, right? If you want to try this on your own, check out the quick start here. See you next time.